Worker node overview. A worker node provides a running environment for client applications. Though containerized microservices, these applications are encapsulated in pods controlled by the cluster control plane agent running on the master node. Pods are scheduled on worker nodes, where they find required compute, memory, and storage resources to run, and networking to talk to each other and the outside world. A pod is the smallest scheduling unit in Kubernetes. It is a logical collection of one or more containers scheduled together, and the collection can be started, stopped, or rescheduled as a single unit of work. Also, in a multi-worker Kubernetes cluster, the network traffic between clients, users, and the containerized applications deployed in pods is handled directly by the worker nodes, and it is not routed through the master node. A worker node has the following components: container runtime, node agent, Kubernetes, proxy, proxy, add-ons for DNS, dashboard, user interface, cluster level monitoring, and logging. Worker node components, container runtime. Although Kubernetes is described as a container orchestration engine, it does not have the capability to directly handle containers. In order to manage a container's lifecycle, Kubernetes requires a container runtime on the nodes where a pod and its containers are to be scheduled. Kubernetes supports many container runtimes. Docker, although a container platform which uses containers as a container runtime, it is the most popular container runtime used with Kubernetes. CRI-O, a lightweight container runtime for Kubernetes. It also supports Docker image registries. Containerd, a simple and portable container runtime providing robustness. Fluentd, a hypervisor-based container runtime for Kubernetes. Worker node components, node agent, Kubernetes. The Kubernetes is an agent running on each node and communicates with the control plane components from the master node. It receives path definitions, primarily from the API servers, and interacts with the container runtime on the nodes to run containers associated with the pod. It also monitors the health and the resources of pods running containers. The Kubernetes connects to container runtimes through a plugin-based interface. The Container Runtime Interface (CRI). The CRI consists of protocol buffer, gRPC API libraries, and additional specifications and tools that are currently under development. In order to connect to interchangeable container runtimes, Kubernetes uses a SHIM application, which provides a clear abstraction layer between Kubernetes and the container runtime. As shown above, the Kubernetes acting as gRPC client connects to the CRI SHIM acting as a gRPC server to perform container image operations. The CRI implements two services, image service and runtime service. The image service is responsible for all image-related operations, while the runtime service is responsible for all the path and container-related operations. Container runtime used to be hard-coded into Kubernetes, but since the CRI was introduced, Kubernetes has become more flexible to use different container runtimes without the need to recompile. Any container runtime that implements the CRI can be used by Kubernetes to manage pods, containers, and container image. Worker node components, Kubernetes, CRI streams. Streams are CRI implementations or interfaces specific to each container's runtime supported by Kubernetes. Below, we present some examples of CRI streams. Docker stream. With Docker streams, containers are created using Docker install on the worker nodes. Internally, Docker uses container to create and manage containers. Docker stream, Kubernetes, CRI, Docker stream, Docker, containers, container. CRI containers. With CRI containers, we can directly use containers to create and manage containers. CRI-O. CRI-O enables the use of any Open Container Initiative (OCI) compatible runtime with Kubernetes. At the time this course was created, CRI-O supported runc and clear containers as container runtimes. However, in principle, any OCI compliant time can be plugged in. FlagT enables CRI implementations through hardware virtualization, aimed to achieve a higher level of security and isolation than the traditional Linux OS level containers based on C groups and namespaces. The FlagT CRI shim is aimed at enabling Kubernetes to interact with Kata containers. Worker node components, proxy, Kuberproxy. The Kuberproxy is a network agent which runs on each node responsible for dynamic updates and maintenance of all networking rules on the node. It abstracts the details of paths, networking, and forwards connection requests to pods. The Kuberproxy is responsible for TCP, UDP, and SCTP string forwarding and round-robin forwarding across a set of paths backends, and it implements forwarding rules defined by user through service API objects. Worker node components, add-ons. Add-ons are custom features and functionality not yet available in Kubernetes, therefore implemented through third-party paths and services. DNS. Custom DNS is a DNS server required to assign DNS records to Kubernetes objects and resources. Dashboard. A general-purpose web-based user interface for custom management, monitoring, collects custom-level container metrics and saves them to a central data store. Logging. collects cluster-level containers, logs, and saves them to a central logs store for analysis.